Hi everyone, welcome to my tutorial on heaps and data structure. In this video, I explain what heaps are, how they work, show some example in Java, also talk about real-world application. What is a heap? A heap is especially kind of binary tree. The key idea is the heap property. Number 1. In a max heap, the parent is always greater than or equal to its children. Number 2. Mini heap. The parent is always smaller than or equal to its children. This makes heaps really good for quickly finding the maximum or minimum elements. A heap example. Here's an example of a max heap. The largest number 50 is at the top, and every parent is greater than its children. Notice that this is not the fully sorted tree, but the property is maintained. Heap operation. There are two main operations. Insertion. Add a new element at the bottom, then bubble it up until the heap properly is restored. 2. Deletion or extract a root. Remove the root, move the last element to the root, and then push it down or heapify until the structure is fixed. Java example. Main heap. In Java, we can implement heaps using the priority queue class. By default, it creates a main heap. For example, if we add 50, 20, and 40, the smallest element will always come out first when we pull the queue. Java example max heap. To create a max heap in a Java, we use a custom comparator. Here, I added the same numbers, but now the largest elements come out first. So max heaps are perfect when you always want the biggest value quickly. A real-world application. Heaps are super useful in real life. In a priority queues like a CPU scheduling or printer jobs, they decide which task goes first. In a graph algorithm like Dijkstra or Frame, heaps help pick the next best node. In event simulation, they decide which event happens next. And in memory management, they help with allocating resources. Line 2 and 3. Import statement. First, we import java.util.priority queues and java.util.collections. The priority queue is the data structure we'll use to create the heap, and collection helps us reverse the order to turn into a max heap. In line 5, class declaration. We create a public class called basics max heap example. This is just our main class to run the program. The line 6. Main method. Inside the main method, all our code will run when we execute the program. In line 8, creating the max heap. Here we create the new priority queue called max heap. Normally, Java priority queue creates a main heap by default, meaning the smallest value comes first. But since we want a max heap, we pass in the collection that reverse order, so the biggest value becomes the highest priority. In line 11 to 15, adding elements. Next, we add several elements into our heap: 50, 20, 40, 10, and 30. Every time we add a number, the heap automatically arranges itself to maintain the max heap property, meaning the largest number will always stay on the top. Line 18. Displaying the heap. We print the heap using system that print in. The order might not look perfectly sorted when printed because the internal structure of the heap is a tree, not a list, but it still keeps the largest elements at the top. Line 21. Picking the largest element. When we use a pick, it simply looks at the top elements without removing it. So this will show the largest value in the heap, which in the case is 50. Lines 24 and 26. Removing elements. Finally, we use a while loop with a pole to remove elements one by one. Each time we remove, the heap rearranges itself so the next largest value moves to the top. You'll see the numbers coming out in the descending order, starting from 50 down to 10. The output is there.